Hi, welcome to All About Mechanical Engineering. Today we will see what is a thermal reservoir, refrigerator and heat pump. So according to the definition, a hypothetical body with an infinite heat capacity is called as thermal reservoir, which means a thermal reservoir can supply or absorb any amount of heat without affecting its temperature. Means no matter how much amount of heat is supplied by a thermal reservoir or how much amount of heat is being absorbed by a thermal reservoir, its temperature remains unaffected. The closest example to a thermal reservoir is atmosphere, rivers and oceans, etc. A reservoir which is going to supply heat energy continuously will be called as heat source, and a reservoir which will absorb heat energy will be called as heat sink. Now coming to a refrigerator, a device which operates in a cycle maintaining a space at a lower temperature than the surrounding is called as a refrigerator. So a refrigerator extracts heat continuously from a controlled space, maintaining it at a lower temperature than surrounding. Whereas a heat pump is a device which operates in a cycle maintaining a space at a higher temperature than the surroundings. So the pump supplies the heat continuously to a space by absorbing heat from low temperature surroundings. So as per the schematic diagram, a refrigerator extracts heat from a cold space at TL and supplies it to a high temperature surrounding at TH. Now obviously TH is greater than TL. Now extracting heat from a low temperature body and supplying it to a high temperature body is not possible naturally unless and until there is an external work supplied to the system. So, in order to work, a refrigerator must be supplied with work input. So, here this sentence should be added at the cost of work supplied to it. Whereas in case of a heat pump, it also extracts heat from a low temperature surrounding and supplies it to a high temperature space. Extracting heat from a low temperature region and supplying it to a high temperature region will require an external aid, that is work input should be there for a heat pump as well. So at the cost of work supplied to it should be added to heat pump as well. Now refrigerator and heat pump both works on the same cycle. They extract heat from a low temperature region and supply it to a high temperature region. Yet both are different. Why? Because their objective is different. In case of a refrigerator, the objective is how much amount of heat is being absorbed from this cold space in order to maintain it at a low temperature than surrounding. Whereas in case of a heat pump, the objective is how much amount of heat is being supplied to this space in order to maintain it at a higher temperature than surrounding. Now the relation between coefficient of performance of a refrigerator and coefficient of performance of a heat pump. So what is coefficient of performance? As in case of heat engine, we have efficiency. So in case of refrigerator and heat pump, we have coefficient of performance. For refrigerator and heat pump, we have seen these diagrams, and the terms here are energy absorbed is equals to QL, energy supplied is equals to QH, work supplied to the refrigerator is WN, which can be stated as QH minus QL. Coefficient of performance for a refrigerator is given by refrigerating effect divided by work input. What is the meaning of this refrigerating effect? That is the amount of heat extracted from this cold space. So it can be written as QL divided by WN. Now WN can also be written in this form. So it becomes QL divided by QH minus QL. So this is the coefficient of performance for a refrigerator. For a heat pump, we have the same terms, but here QH we have written as QL plus WN, which is just a rearrangement of this. In case of heat pump, coefficient of performance is given by heat supplied by the pump divided by work input to the pump. That is, QH will be in numerator here. So COP of heat pump is equals to QH divided by WN, which can also be written as QL plus WN divided by WN, because we have replaced QH here with this term here, and On simplifying it, we get QL divided by WN plus 1 can be written in this manner: COP of heat pump equals to 1 plus QL divided by WN. So, replacing this term with COP of refrigerator, we get the relationship COP of heat pump equals to 1 plus COP of refrigerator. This is the relationship between COP of heat pump and COP of refrigerator. Hope you have enjoyed the video. See you again with another video.